but let me see. I'm going to start to catch up to you.
What is the minimum expected number of heads?
Bring the mood lights.
It was Jordan, I guess.
So then, plus or minus 2 statements.
Change this. Poor little dude. Shipoo. Okay, you're good. All right, guys. I'll start number 2. So this guy here, if I ever ask you to draw it, I normally am pretty nice and I say indicate the height, but without the height it's not complete, right? So this will go from, pretty sure everybody got this one okay. It's one big box. How do I know it's a big box? Because it said it was uniform. What's the height?
117.
17, yeah. I lock it. So then between 23 and 27, so 23 to 27,
4.
this has got a width of
4.
4. So then the area is equal to the probability is equal to
4
4
times
times
1.
117. And what is 4 divided by 17? 0.2353. Okay. Sounds good. And you can make that 23.53% if you want to, blah, blah, blah. Okay. So, I mean, this is exactly like the dartboard, except it's just rectangles. This rectangle takes up this percentage of the whole thing. So, of course, there's this percent that something would get in here. Because that's the percentage that that represents. Okay, maybe. More than 22 minutes. 100%. Another way to look at that is more than 22 would be all the way here. That's a width of 17 times 117 is 100%. So you can kind of, you can do the work if you want to, but it's an easy answer because that's everything. So 100%. And this one is doubly something.
0.
0. 2 reasons why it's 0. Even if I would have said 28, that would have been 0. Yes, I want to make sure. I just picked a bad number. I think I changed these numbers and I forgot to change this number. Even if it was 28, that's in there, but it's still got no area, correct? And 8 isn't even in there. So it's like 0 for 2 reasons. Okay, is that cool? Or understood? Yes?
Explain again why it's 100%.
For this guy?
Yeah.
Okay. It's the same thing. I'm not sure which. All right, I'm going to try to answer it and let me know if this is not the hang-up. More than 22. If you shaded in what's more than 22, do you leave anything out?
Wouldn't I be leaving out 22?
Say again?
Wouldn't I be leaving out 22?
Perfect. Okay, that's what you're hung up on. Guys, real quick. More than 22 definitely leaves out 22, correct?
Yes. Yeah.
What's the probability x equals 22?
0.
0. So I could have said at least 22 minutes, which would have made the question this, but that's equal to that because any individual item has a 0 probability. So I sort of like that. That was your hang up because that's perfect, but it's just something we're not used to. Infinite number of possibilities means any individual thing has a 0% chance of happening. By the way, I will say this. I've decided because I told my other class this. Okay, real quick, what I'm about to say is a weird concept. I'm just going to throw it at you to see if anybody sort of like gets interested. You do not need to understand the next whatever. I'll tell you when it stops. You do not need to understand it. It doesn't make sense that any individual thing would be 0 because then to get this one to add up a bunch of individual things, if they were each 0, wouldn't that just add up to be 0? Again, remember, everything I'm saying right now, you don't have to understand it. Just throwing it out there. What's infinity mean again? Is infinity a number?
No.
It's the answer. It's the best answer you can give, though, is if I ask you what's the largest positive number. It's the best answer you give. It's not even an answer. It's just like you'll have to just keep going. Infinity is a process, correct?
Yes.
Now think about this. What is the smallest positive number? Huh? No, smallest positive number. Is 0 positive? Nope. So what is the smallest positive number? Isn't 0.7 less than that?
Yeah.
Isn't 0.1 less than that?
Yeah.
Isn't
Infinitely
0.01 less
small.
than that? Isn't 0.001 less than that? 0.0001. So anytime you think you got the smallest, can't you cut it in half?
Yeah.
The same way if you ask a little kid, give me the biggest number, and then you say double that, and you blow their mind. Like, oh shit, do these things ever end? Are you guys sort of with me?
Yeah.
So, I've already said too much, I'm sorry, I've already spent too much time. The real answer to the probability of x equal 28 is something called iota, which is the smallest positive number. And again, when I ask you this question, it's 0. If you want to write iota, it's here, right? If you want to look up iota, it's IOTA. It is the idea of the smallest positive number. So young Jeff taking this shit, the instructor was saying this, and I said, wait, if you add up a bunch of things that are 0, it's 0. And then he said, all right. And then he did everything I just did, right? He said, okay, the real answer, okay, so I always like to do that, just in case anyone, now starts, you better start understanding everything I say after this. Okay, good. All the other shit about iota, it's okay if you don't get it. Sorry, I just had to throw that out there. So it's 0 for most humans. Okay. Is that all right? So that's why, if I say greater than 22, this doesn't add anything officially. Like, so coming back up here, what are the main things I need to summarize as I start to answer my own question? Good job, Jeff. N, P,
X.
Q, and then whatever the X is for that problem, right? So what's N?
211.
N is always the total number of things. It is the one variable that never changes. P?
0.12.
Good. Probability of success. We're looking for worried people, so I want the probability that they're worried, right? Q?
0.88.
0.88. And in this case, X is 19. I like it. And now, how do I set up the formula for exactly 19? It would be, I got 211 people, I want to choose 19 of them. So how many successes do I have? 19. How many failures do I have?
192.
192. Where did the 192 come from?
211 minus
211 minus 19, because the exponents always have to add up to be the total, because you're just breaking the total into two groups. Okay, maybe. Okay. And then throw that in the old calculator. What do you get? 0362?
Yeah.
That sounds familiar. I like it. And then you can make that 3.62% if you want to. So very small chance you would get exactly 19. Okay, what about the mean and standard deviation? What are those formulas? NP, so it'll be 211 times 0.12, and what do you get?
0.3.
Sounds right. So at any group of 211 US workers, I would expect to find about 25 who are worried about this, right? Have this irrational worry. Standard deviation squared of NPQ.
4.723.
I love it, guys. Go even further. That kicks ass. All right. By the way, real quick, remember standard deviation's got to be at least 3 places. So if you just make everything 4 places, your ass is covered. Does it make sense? And of course, we're about to talk today about why z-scores will be 2 places, but you'll see. So pretty cool that's the mean, that's the spread. Those are the 2 numbers I always want to know. It's really interesting the number of people that did this problem and then were confused about this, and I think it's just the wording I decided to use. What I'm really just asking is, where does unusual start? And of course, unusual starts 2 steps away. So a lot of you guys did the work on part D that I was asking for in part C, which is fine. So if you want to do it less visually, you can go, the min would be the mean minus 2 standard deviations, and the max would be the mean plus 2 standard deviations. Or you can do that visual like we've done, put the mean in the middle, go up 2 steps, go down 2 steps. Whichever way you do it, what numbers do you get? What's the min?
15.8794.
Okay, and the max,
34.7606.
do it again.
34.7606.
Okay. So I would expect to get somewhere between those two. Anything outside of there would be unusual. I could do something similar with heights, and then the max height, if I saw somebody taller than that, that might correlate to somebody going, whoa. You guys semi with me?
Yeah.
So is 14 unusual?
Yeah.
If I take 211, find only 14, that's unusually low. Is that very unusually low?
No.
No, but it's still unusually low. So, for example, where this is used in real life is, do you remember last time I talked about Aaron Brockovich and the cancer and the water, blah, blah, blah? Did I do that here with you guys?
Yeah.
Okay. So there's a known occurrence of cancer, so if I calculate what the min and max usual expected rates of cancer would be, and I notice in some area there's more than the highest it should be, that could be a reason to go in and check, especially if we get complaints about people's health, about the taste of the water, whatever, that could be a reason to go in and check. Maybe it's the air, maybe it's the water, maybe it's the food, maybe it's whatever, right? It could just be a random occurrence. You could randomly have a small group of people suddenly just have more cancer than normal, just without any reason. It just happened. That's the nature of randomness, right? All right. Yes, somebody with me? So that's a real life application of this idea. Okay, you. Is there any questions on that whole sheet?
Yes.
Wait, what was D?
Oh, D would be yes. Why? Because it's out here. 14 is way out there. I'm sorry. It's outside of the usual. So this is the usual. So if I ask you guys right now, what's the tallest you would expect, tallest person you would expect to see just walking amongst a bunch of just random people? Everybody would have a slightly different answer, I'm sure. So Samaj said 6'4". Right, kind of depends. If you play basketball, your answer would probably be higher because you're thinking about the people you're around, right? Also, whenever you look in the mirror, I'm like, there's somebody. The lowest, what's the shortest person you would expect to see? 4'11", 5 foot, something, right? So if we actually took this is really curious. I gotta check this. The last time I checked, which is a long time ago, unfortunately, was the average height of an American male was 5'9". And the standard deviation was 2.8 inches. So you could actually take 69 inches, add 2.8 twice, and subtract 2.8 twice, and see what the max and min expected heights are. And see how close it is to your own perceived notions, right? Does that make any sense?
Yeah.
Okay, I like it. I talked a little bit about it, like why did they make the door as tall as they did? So that only a certain percentage of people had to duck, so they only had a certain percentage of complaints, right? Does that make sense?
Yeah.
Or a certain percentage of people, see you later, that'll be on the floor, right? Okay, I think I've wrung as much out of this as I can. Anything else about this? Okay. So let's look at this side, this weird side. It starts off nice. That's not gonna be a bad thing. We're gonna do this together. I think some of you guys have already started looking at these. I'm gonna flip a coin 14 times, so of course there's 14 trials, 14 times I'm doing something. Assuming it's a fair coin, and it even tells me that it is a fair coin, so it's gonna be 50-50, is that cool? You guys semi with me?
Yep.
50-50 chance. So how do I set up the probably for 9 heads?
14C9.
Choose 9.
Choose 9, I like it.
Times 0.5.
9.
Does anyone notice a shortcut whenever you have 50-50? I don't care whatever these isn't it always gonna be 0.5 to the 14th?
Yeah.
You have the same base? Do you have to know that? No. Do you ever have to use that? No. Doesn't matter, just pointing it out. So what do you get when you throw out the old calculator?
0.1221.
Into 2?
Okay.
It's my memory, I don't know.
2, yeah.
Now what about this guy? Yeah, at least one head would suck, because you have to do the formula for 1, for 2, for 3, for 4, up to 14. So I'd much rather do 1 minus probably none. And what's the probability of none? 14, choose 0, 0.5 choose 0, 0.5 choose 14. And you end up getting another E dude, right? You get like 6 point something E negative 6?
5.
5?
Yeah.
Is everybody sort of with me?
Yeah.
Probability of at least one. Anytime the question they ask me has got more work than the opposite question, do the opposite question and then do 1 minus what we got. You get 0.99994. Jeebus. So if I flip a coin 14 times, what piece of that work tells you the probability I don't get any heads? Somewhere in there we did that work, right?
Yeah.
It was probably I don't get any heads.
Oh.
Yeah. So would it be proof that a coin is weighted if I flip 14 heads in a row?
Yeah.
Would it be proof? Let me ask this. Would it be evidence?
No.
Yes. Would it be proof? No. That ain't no proof. Could you flip 14 heads in a row on a normal coin? Of course you could. How likely is it that you do that? Very unlikely. So that is evidence that it's weighted. It's definitely not proof, because it could happen, right? Sort of like, you guys, I'm certain, have paid attention to some court cases where they have DNA evidence. If you have DNA match of blood with your own DNA, the blood at the scene, your DNA, does that mean you did it?
No.
Does that mean that's your blood? No. Very likely is, it actually is very likely, but it's not 100%. It's actually a little less than most people think, but it's still a pretty high probability, but it's not 100%. It ain't proof. It's pretty good evidence, especially if you couple it with a lot of other things, witness testimony and whatever, and you can't account for your time and blah, blah. You with me? If you combine it with stuff, then you got a really solid case, but by itself, if that's the only thing you got, you can throw holes in that sucker, right?
You need a confession.
Even a confession, you know?
Yeah,
A little bit, get a confession.
It still would be circumstantial.
Huh?
It still would be circumstantial evidence, or at least considered that.
Yeah, even if it was 100%, it's like, did somebody get your blood somehow and put it there? You know, you got all, well, you know, I'm always thinking about the, back in the 90s, we had a great thing with the O.J. Simpson case, right? There's a lot of interesting things about that case with the blood and the glove and the blah, blah, blah. Anyway, so that was everybody's kind of first inkling of DNA is not, everybody sort of had this idea that DNA meant you're done. When actually, no. We don't match all of the DNA. We match certain markers, and somebody else could have those same markers. So, yeah.
And that's mainly because DNA, like typing and all that, is still relatively new with science and everything, if you think about it, because it only started being used more in like the late 80s to 90s, especially in cases like that, so that's why it's still considered circumstantial, because it's still not good enough to be considered like 100%.
Yes. So it could strengthen a case. It can't make a case.
Yeah, exactly.
I like it. Okay, enough of that. Sorry, we're not suddenly in an AOJ class. Although I think I want to take an AOJ.
7.
Yeah, so this one, and you guys would be able to tell me this anyway. If I said you flip a coin 14 times, how many heads do you expect? You guys would say 7, right? So that matches up, because the other name for mean is,
Average.
another name for mean, another name for average is
Expected.
expected value. So how many heads do you expect if I flip a coin 14 times? You expect 7. So the work better freaking come out 7, because we already know the answer is 7, right? Thankfully it came out to be 7. Yes?
Yeah.
What about the spread?
1.8708.
1.871?
Yeah.
Okay. So I don't know if you guys remember, I asked the question a while back, if you flip a coin 500 times and you get 251 heads, you're obviously not gonna freak, because you expect it to be somewhere close to 250. But what the hell does close mean, right? 260, is that weird? Probably not. 280, 350 out of 400 heads, you're like, okay, that's weird, right? So here we actually have a way to formalize when does weird start. So the minimum expected number of heads, It's the mean minus two of these. Do it again, sir.
3.258.
3.258, and then the max,
10.741.
10.74 or something?
Good.
Okay. Alright, that was just a little quick review. I'm not gonna really do much with that, but if you flip a coin 14 times and you get 11 heads, that's actually evidence that it's been tampered with. Right? Is it really strong evidence? No. You better flip that sucker 100 times, and then that will mean something, right? You guys with me?
Yeah.
In fact, I don't know if you guys, this is one thing I've been meaning to try to slip in somewhere. If I ask you guys to write, just don't even flip a coin, but just, actually do this. Somewhere, come up with the random list of tails and heads. Just make a like tail, head, tail, tail, head, head, tail. You with me?
Yeah.
If I flip a coin 10 times, you make up a random assortment of what can happen. You guys understand?
Yeah.
I've never tried this actually live. We'll see what happens. You guys understanding what's happening?
Yeah.
And then I'll need to see if somebody will let me borrow $100. I mean, a coin. I don't have any coins on me. And we'll all watch Jeff flip the coin. And one working eyeball, so this should be exciting. Don't throw it at me. All right, I got one right here, guys. Thank you. Sure. Yeah. I guess I gotta trust you. Let's see. She's like, let me give him my weighted coin. Okay. Everybody, get ready to be excited. Why did I? Yeah, see, I got no vision. Did I tell you guys I got no vision? So real quick.
What happened? Your brother.
CR, what is it called? I forgot the name of it. Retinal occlusion
What?
in the back of my eye, yeah. So the blood black flowed and damaged the back of my retina. So have you ever looked, yeah, all you have like pull your shirt up and look through? So it looks like that. Right now, I can't.
No.
It's weird. So right after it happened, which was January 2019, when I was teaching class, somebody would come up to hand me a paper and I would go,
Wow.
where is it going? So I had to tell my class, and now it's gotten better, so I don't normally tell anybody anymore, but just so you know, oh, now I'm gonna lose your quarter. So that was tails, that was tails. So as you watch me miss it in the air, give me a little bit of leeway. Real quick. One of my colleagues had a student come in and they brought their little son, and he had a little hoop, basketball hoop, little tiny Nerf hoop thing. And the kid was playing, and I came around there, I was watching, and the kid looked at me and said, you wanna try? And he threw the ball at me, and I missed it. And he looked at me like, oh, did no one ever play catch with you? All right, here we go, everybody. Oh crap, wait, I caught it. Okay, that's tails.
That's the second.
Somebody keep track of this.
Was that the first?
Two tails. Two tails. All right, that'll work. That's a heads. That's a very interesting coin. What is that? Oh, you're gonna confuse the hell out of me. Oh, that's funny. Your tails has a head on it. That's awesome. Okay.
I'm sorry.
Oh, Jeebus. No, so that's the third tail in a row, actually, guys. TTT. That's a heads. So TTTH. You guys with me? Okay, we'll do that. Heads.
No.
Okay, we'll just do a little flip. Tails. That's a little more of a reaction.
Oh, no, because this is exactly what I've written down so far.
Really?
Yeah.
Heads.
Again, too.
You're gonna freak me out. What is it?
Heads.
Tails.
Oh my gosh.
Alright. I was gonna have to wear tinfoil on my head. Tails. How many is that now? I've lost
That was
it.
done.
That's it.
That's 10?
No, that's 8. We got 2 more.
That's 10. What?
Some are telling me it's 9.
It's
Nine.
nine.
That was next.
It's nine.
Oh, yeah, you're right.
That's nine.
Alright, here's one more.
Very.
Tails. Alright.
Okay.
Somebody read it back to me.
Tails, tails, head, tails, tails.
Alright, now real quick. Anytime, now compare it to what you wrote down, which is really funking me out. But if we have enough time the latter part of the semester, we're all gonna test each other for ESP, by the way. Right, let me give this back before I just put it in my pocket and turn it in. Anytime somebody tries to model random things, they mess up. You guys, anybody, it's just a human thing. We'll switch from tails to heads too often. But if I just let something randomly happen, there will be a string more often than we think. There'll be a string of tails or a string of heads. But if you just try to model randomness and try to make it up, you're gonna switch between tails and heads too much. Now you did something yourself. Yeah, I love
I
it.
only
I
missed two
got
on that.
80%.
Huh?
I only missed two on that.
You only missed two? Okay, that's from me.
Yeah, I only missed-
Anybody get it all right? Anybody get it all right?
Missed one.
You missed one. Okay. Okay, normally somebody would say play the lottery. I would say don't, because you already used up all your luck, so don't play the lottery. Okay. All right, sorry, that was a little side note. I have no idea, just because we're flipping coins here. So this picture is just having a computer do all of the values. So look here, 9 was 0.1222. This computer is kind of dumb. It rounded to 3 places, but too bad for it. You guys with me? 0.122, 0.122, right? So this is just every possible value. And of course, it could be anything from 0 to 14 successes, correct? In this case, 0 to 14 heads. What does 0 plus mean? I mean, what did we get for the probability of none? When you say that's just above 0?
Iota.
It's definitely nowhere near iota. That's billions of times, billions of billions of billions of billions of billions of billions of times bigger than iota. But anyway, no, stop it up. Isn't that, for most humans, isn't that just above 0?
Yeah.
And that's what this means. That means just above 0, right? You guys am I with me?
Yeah.
So if I create a histogram out of this, there it is. What strikes you about the shape of this?
Symmetrical.
It's
There it is. Bell shaped. Looks normal curvish, right?
Yeah.
So we're gonna come back to this handout not too long in the future, so make sure if you normally burn these or throw these away or make paper airplanes and throw them down onto the football field or something, don't do that with this one, okay? Make sure you bring this one back. Because we're gonna finally come up with a way to tell if a binomial is normal enough. This looks like it's probably normal enough. Why do you think that is? The mean was 7, correct?
Yes.
And in this case, it's the tallest peak. In general, the tallest peak will be very close to the mean. It doesn't have to be the mean, believe it or not. But in this case, it is. So didn't it have room to grow and then room to shrink?
Yeah.
Yes.
So real quick, watch. What if the mean had instead, what if I had a weighted coin and P was 0.01 instead? And I flip it 14 times. What would the average be now? 0.01 times 14, what's that?
0.14.
0.14, you with me? Wouldn't the tallest peak be around 0.14? Would that have room to go up and come back down? No, good, all right, so that just laying some groundwork for later. Why is this normal? Because it's far enough out, so it's got room to go up and room to come down. So that we'll come back to that in the future, okay. Notice this also. What's the probability x equals 6, for example?
18.3.
Right? And what's the area of this rectangle?
18.3.
Yeah, it's 1 across, you guys see that?
Yeah.
And 0.183 up, so isn't that area 0.183?
Yeah.
Okay, cool. I like it. Okay. Not worry about this at the moment. So the probability is connected to the area, just like we did with a dartboard, just like we did with uniform distributions. When I have a uniform distribution, it's just rectangles, so that's easy as shit, right?
Yeah.
When I have a normal curve, if I wanted to know the area between these two, is that a shape that we have an area formula for? The shape.
Oh, yeah.
Yeah.
Oh, good, what is it?
Oh, no.
What is the formula for curvy side dude?
No.
We don't have a formula for that, do we? You guys am I with me? You can approximate it with the trapezoid, right? But that's not good enough. So, if it's a uniform distribution, I don't need any help. I can just get the area of a rectangle done, correct?
Yeah.
Do you all agree we need help when the shape is curved on one side? I don't have geometrical formulas for that. I need some help. Do you guys agree?
Yeah.
Okay, good, because I'm gonna give it to you. Okay, here. So what this is empirical rule blown up. So even before I give this to you, remind me about empirical rule. Within one standard deviation in a normal curve, 68%, right? Let me see, I just want a little snippet. So, just so you'll buy more into this thing, a normal distribution within one standard deviation, 68%, right? Pretend like I did that symmetrically. There you go. 68% inside, what percent outside?
32.
32%. So how much on that side? 16, because it's symmetric around the mean. It cuts it in half, right? So there's 16% here below. What would the z-score be?
Z minus 1. Yeah.
Negative 1. It's one step down, correct? Everybody with me?
Yeah.
So whatever the shit I'm about to give you, if it's supposed to be all the answers to the areas, when I look at the right place for this area, it better frickin' be 16%. Or we can all throw that shit out and take a big chunk of the semester off. And now you're all like, please tell me he made a mistake somewhere. Oh, I didn't. That's too bad. Now, if any of you guys go into a field that requires statistical analysis, oh sure. You're obviously going to be using software packages to do. You guys are going to be using software to do a lot of the work.
Yeah.
We ain't there yet, so I get way too many people that tell me, well, my last stats teacher just let me push these buttons. I don't give the first shit what your last stat teacher did. Okay. Now you got me. All right, guys, so this is not the most intuitive thing. Okay, and everybody sounds appropriate levels of excited about this. So first thing to notice, if, for example, I wanted to look up the z-score negative 3.28. Do you see how the first decimal place is here? Negative 3.2, negative 3.28. Do you guys see how that works? Negative 3.28. So the second decimal place is up here. So if we get that 0.0005, negative 3.28. You guys all see how that works?
Can you say it again?
Sure. I'll zoom out a little bit. So for example, let's do another one. If I want to look up negative 1.93, negative 1.9, see negative 1.9? Yeah. 3. That's the answer.
Yeah.
Okay. By the way, trust me, it could be so much worse. Back when I took this, I got like 5 sheets of shit because it was done differently. This is the best. It's 2-sided sheet. Are you kidding me? All right. Now, what does the number mean that we just looked at? Well, look at the picture at the top. By the way, real quick, before I forget, do not write any notes on this. You can put your name on there if you want to. You're going to use this on quizzes and tests. So if I see any notes, if I see any markings that I'm not sure what it means, you could lose points because I'm an asshole. Don't forget that. Right? Some people lost points on their formula sheet. They were mad at me, and I said, "I told you. I told you it would happen. Be as mad at me as you want to." Right. Same thing here, right? Whenever you look up, whatever z-score you look up, the chart will single-mindedly tell you the area below it. For example, don't we already know it should be below negative 1.00? What should be below? If I look up negative 1.00, what should there be? 16%, correct? Remember, empirical rule numbers are rounded a little bit, so it should be close. So let's look up negative 1.00. Negative 1.00. right? That's 16%, correct?
Almost.
You guys semi with me?
Yeah.
So if you understand and remember empirical rule, empirical rule is in here. Just a lot more shit. So we used to only know 1, 2, 3. So many guys are like, "What was fine, Jeff?" Now we know a lot more in between, correct?
Yeah.
With technology, I could look up a z-score of negative 1.2944763. I don't give a shit. Our answers are going to be a little wrong. I don't care. Because I am of the mind that if you do this, you'll get a better feel for how things are spread out. You're going to actually feel more in connection with what the hell you're doing instead of pushing a button and seeing a number. Maybe I'm wrong. But oh well. Until somebody proves it to me, I'm going to keep doing this crazy shit. So, let's do a couple of quick little examples. If I can find, here we go, perfect. So we'll do a couple together here. So what you're gonna see is, it's gonna say, given a standard normal distribution. And all that means is, everything's been turned into z-scores, right?
Yeah.
So for a normal curve, what is always right in the middle? The mean. If I've turned everything into z-scores, what does the mean become? So what's the z-score again?
The number of standard deviations.
Number of standard deviations from the mean to the data point you're interested in, right? What if I'm interested in the mean? How far is the mean away from itself? 0. Okay, so the mean will always be 0. So the word standard means it's been turned into z-scores. I've standardized it, right? So if I say, given a standard normal distribution, find the probability that z is less than 1.07, right? Can you draw that picture for me? You know it's normal. You already told me what goes in the middle, right? I've had people in the past that had trouble making the shape. So if you have trouble making the shape, you can make a triangle, it doesn't matter. You just need some kind of visual anchor. Try to make the shape as best as you can. Every time I draw it, it's a little different, but it just needs to look like, that. It could even look like this. Little ghost dude, right? But maybe don't do that. What's in the middle again? Good, the mean, which is 0 in this case, I love it. Where is 1.07?
To the right.
Is everybody cool with that? For some reason, I get people that they'll put 3 here. I'm like, wait, what? No. So the picture is supposed to help you. Can anyone tell me can you shade in the area it wants from us?
To the left.
Yeah, so the funny thing about inequality symbols, if the variable's here, this is a arrow. It's telling you which way to shade, right? Do we know if it's gonna be more or less than 50%? More, because the mean cuts it in half, and this is definitely more than that, correct? So at the very least, I know if I get an answer like 0.17, I am wrong. Because it's supposed to be more than half, does that make sense?
Yeah.
So at least we can identify when something's really out of whack, right? Now, look at the chart. What's the chart built to, what 2 things do I need to be able to use a chart? I need what kind of distribution?
Standard.
Normal, I like it. And I need to have turned everything into z-scores, right? So then I can use this chart. And here, everything was z-scores to begin with. So if I look up 1.07, what do you find? Then I gotta use the positive side, right? 8577? Yeah. So 1.07, 8577. Is that good? So the minute you look up a z-score, it tells you the area below. Do you see how I'm putting an area up here, and I put the z-scores down there? You with it? Because let me ask you that. Is everybody cool with that? Do you see how that's the answer?
Yeah.
I'm
Yeah.
done. Because the chart tells me the area below, and the question wanted to know the area below, right?
So the answer would just be the drawing or point?
The answer would be this, why I circled 8577. Yeah. So the probability that a z-score is less than this will be 85.77%. So if there was a test where the grades were normally distributed, what's the probability that your test grade was 1.07 standard deviations above the mean? What's probably that, the probability that somebody scored less than you would be 85.77%. Maybe.
Okay.
Okay. Now what about this question? Find the probability that z is greater than negative 0.39. Take a second and see, or maybe several seconds, and see if you can draw that picture. Shade in the area it wants. What does it want? Let me make sure everybody's good. So you can always draw this. We got a standard normal, so I know it's gonna be normal, I know it's gonna be 0 in the middle. Where's negative 0.39?
To the left.
Just a little bit to the left, right? Just a little to the left, correct? And then which way do I shade?
This way.
Okay. To the right, is that cool? Again, just points you in the right direction. So when you look up negative 0.39, will that be the answer?
No.
Because the chart very single-mindedly spits out the area below. So look up negative 0.39.
3483.
I love you guys. So does everybody agree? Look up negative 0.39, do you get
3483.
3483?
Yeah.
And like Milad just said, does it make sense that that's not the answer? And I can see visually, I was really nice to myself. I drew the picture, I shaded the answer. That isn't the answer. So how do I get the rest of it?
1 minus.
1 minus this. There you tell you guys the shortcut. I know you have calculators, but make this 9, makes this 9, makes this 9, make that 10. 6517?
Yeah.
So the chart will always just tell you the area below a z-score. It just always will tell you that. And if that's not what you want, we're the humans, we gotta do a little adjusting. Take a minute, everybody. If there's no questions on how I got that answer?
Yes, because for the first one you didn't do, you
I
just
didn't
got,
have to do 1 minus, right?
yeah,
Because the chart tells me the area below and the question wanted the area below, right? What is this question one? It wants the area above.
Above.
So when I look up the chart's answer, I'm like, damn it, it's the opposite. So then 1 minus. Look up positive 0.39. Do it. Look up a positive 0.39 z-score. David Blaine. Maybe it's not David Blaine level, but why does that make sense? Because the normal curve is symmetric. So the area above negative 0.39 is the same as the area below positive 0.39. If you don't understand what I just said, does it matter? No, because we just did that problem. That problem is done. I'm just telling you about a small shortcut, if it makes sense. If it doesn't make sense, forget about it. Right? Is that all right? It's a little bit of symmetry there we can use to our advantage. Word up. All right, what about this? Sorry. Ready? Let's do negative 2.83 is less than z, is less than 0.55. Oh, shit. So first draw the picture, right? First draw the picture. Sorry. I feel good loopy today, I tell you. Draw the picture. Another way to say when you see a three-sided inequality, left, right, and inside, is to say z is between those two. So now you know what the visual should look like, right? So what goes in the middle again?
0.
Why does 0 go in the middle? It's a standard normal. So if I had a normal distribution that wasn't standardized and the mean was 12, 12 would go in the middle. Does that make sense?
Yes.
So it's not always 0. It's 0 because it's been made into z-scores. Okay, I like it. This is not a very good one, but oh well. So from negative 283 to positive 0.55, I want the area between those two, right? I can never quite, I hate projectors. Okay. Anybody have any suggestions? Because this is beyond the chart's knowledge, right? The chart don't know shit about between. Yes?
You just did the proximity of 0.5, the z-score thing of 0.55 subtracted by the z-score.
Yeah, so everybody look up 0.55. What do you get?
0.7088.
Isn't that the whole area below 0.55? Isn't that too much
Yeah.
for the answer? How much too much? Exactly this much too much. You guys see that? So if I look up the top, dude, that's too much. That's bigger than the answer I need, correct? It's exactly this much bigger. So if you look up the area for negative 2.83,
0.002.
like Joey said, you can just subtract that. Oh man, it's just getting worse. What'd you get, I'm sorry? 0.0023? Okay. I don't know the answers because I just made this shit up on the fly, so.
0.7065.
So 0.7088 minus 0.0023 is 0.7065. I love it. Oh yeah, I forgot to do that. Oh well. Real quick, I'm sorry. Does that make physical sense?
Yes.
Yep.
That area is too much, you slice off the area that is too much, you're left with the area in the middle. Never subtract z-scores. What does a z-score tell you? The official definition is the number standard deviations for the mean. So what does it tell you just talking to me? It's not an answer in the test. It tells you where a data point is, correct?
Yeah.
It tells you where a data point is. If you subtract two z-scores, you're somewhere else entirely now, right?
Yeah.
Does that make sense? So you only subtract areas, you don't subtract z-scores. Now somebody had a hand up. I'm sorry. Yes?
So you only shade the middle part? That's all the content.
You only shade what the question wants, and the question wants what's between negative 283 and 0.55, right? So that's why I only shaded that part. So the picture then is a visual reminder of what the answer is. So when I look up 0.55, I'm like, oh, that's too much. So I want the picture to help you, right?
Yeah.
So when you look at 0.55 and you put the area, you're like, wait, that's too much. I went too far. Oh shit, I better subtract the other part off. Does that make sense? So it's not memorizing subtract, it's just, well, yeah, you subtract because you have to. Visually, it makes sense, you have to subtract. Okay. Oh, what about this? One last thing and I'll let us out. We're getting out early because my earlier class I had several technical problems which kind of delayed, so
Oh.
we didn't have that, so we're gonna get out early. So I'm really sorry. Sure, you guys are like really beat up. Remind me what this means.
We can't see.
I'll tell you in a minute. What does that mean?
Probability of 12.
Nope. Yes. That's the 12th percentile, right? Do you see how this is part 4? We're still in the same problem, correct? So I still have this. Where would the 12th percentile be? What does 12th percentile mean?
12% of the
Or higher than 12%.
12% is below it, correct?
Uh-huh.
So the answer here would be the z-score that has 12% below it. Do you guys get that?
Yeah.
I want you to realize this very first problem we did, isn't 1.07 roughly the 86th percentile? You guys see that? What percentage does 1.07 have below it?
Oh, yeah.
About 86%, correct?
Yeah.
So then isn't 1.07 the 86th percentile?
Yeah.
Because that's what a percentile means, correct?
Right.
So do you notice how this one, I knew the z, but then I had to figure out the percentile. This one, I know the percentile, I gotta figure out the z. It's backwards. So where would the 12th percentile be? What's the mean? The mean is the what percentile in a normal curve?
50th.
50th, because in a normal curve, it's right in the middle. So the 12th percentile would be where? Up here?
No.
Nope, way down here, because it's got 12% below it, correct? Notice how, do you guys agree? I know we're brand new to this today. 0.12, that could be a z-score or an area, right? Very easily, 0.12 could be a z-score, correct?
Yeah.
How did I know to put it up there? And why do I put it there? Because I always put areas up there because they look like frickin' z-scores. Damn it. So it's really easy to forget which thing. So I know that's an area, I put it up there. Every problem we've done so far, didn't we know the z-score already? And we looked out here? And then we looked in the middle and found the area? Now I know the area, don't I? Is this gonna be a positive or negative z-score?
Negative.
This is down there, so look at the negative side. What's the closest you can get to 12% in the middle?
-2.27.
There's just no good way to, oh, there you go. Okay. -2, okay, let's see if we all agree. So try to get really close to 0.12. All right, so it's around here somewhere. There we go. Now we're getting there. Oh, look at that. I picked a good one. Do you guys see those two are the same distance away from 0.12?
Yeah.
So what's this one? What z-score is this one? You guys see how to see it? It's
-1.1.
negative 1.17, right? And what's this one? The other one that's equidistant. Where'd it go? There it is. Negative 1.18, right?
Yeah.
So then the right answer is negative 1.175,
Right.
right in the middle. Because aren't these equidistant?
Right.
Look at this. There's a reason that they have this asterisk here. Because do you see how those are equidistance away from 0.005?
Yeah.
The reason this one gets an asterisk and this one doesn't is because this is one that shows up a lot. If you follow it, it tells you it's 2575. Anyway, that's enough. That actually is a little further than I made it with that time. So obviously next time I'll have a worksheet, we'll work on more of the z-score stuff. We did section 6.1 today.
What section, Professor?
6.1. Please don't forget your stuff.
Yeah.